So this video is going to talk about moles having to do with gases, because liquids and solids have definite volumes and masses. So we can quantify them pretty easily based off of, again, their physical state. But gases are going to be very different because they will, of course, expand and take up the space of any container that they are in. So we need a kind of a different relationship or something else to think about. And I want you to think about Avogadro. He did experiments with gases. Because they are easy to understand because they don't have as many forces between each other. So for gases, we do need to kind of have a standard for how we're going to measure gases at a certain point. So we have something called STP, called Standard Temperature and Pressure, and it stands for the temperature of 0 degrees Celsius in 1 atmosphere, ATM. Atmosphere is, again, the pressure we exist under if we're at sea level. That would be 1 ATM, okay? And we don't talk too much about gases, but that is a unit of pressure for gases. So what Avogadro and other scientists figured out pretty quickly is at this 0 degrees Celsius and 1 atmosphere pressure, 1 mole of any gas happened to fill up a particular volume of 22.4 liters. So this is going to be a standard that we're going to use, kind of like 6.02 times 10 to the 23rd. So 1 mole is equal to 22.4 liters is equal to 6.02 times 10 to the 23 particles, no matter what gas it happens to be. So I'm going to show you a set of calculations with this, but it's a pretty straightforward calculation because of the fact that it's always going to be 22.4 liters. So we have moles to liters first. That'll be the first calculation I show you. So how many liters are in 0.42 moles of O2 gas? Well, it really doesn't matter what gas it is. We are always going to assume, okay, STP. So if I don't write it on my worksheet or something else, you're going to assume that it's at STP. So we are going to set up the following. So I'm going to put liters on top and moles on the bottom. That's just going to be, again, normally how I set up this proportion is always put moles on the bottom, but it really doesn't matter. You could put moles on the top and liters on the bottom, as long as your other relationship over here is the same. So if you want to put 1 mole on top and 22.4 liters, if you have liters on the bottom, that's okay. So again, this is going to be your constant, just like 6.02 times 10 to the 23rd, or its molar mass. But because, again, this is a gas, it doesn't matter what O2 or what gas it happens to be, you're always going to get the same you're always going to have the same setup. So when you take 22.4 times 0.42, you get about 9.4 liters. And again, I have 2 significant digits for that. So why don't you try this one? How many liters are in 1.9 moles of SO2 gas? 1.9 moles of SO2 gas. So again, SO2, a gas. That's all I need to know. I want to find liters. Again, I'm assuming it's at STP. So X over 1.9 is equal to 22.4 over 1 mole. Cross multiply, I get 43 liters. And again, please be sure you're putting units and correct significant digits when you're doing these calculations. So what if we went the other way? Well, all I'm doing is changing where the X is. Okay, so I'm going to take 38.9 liters over number of moles is equal to 22.4 liters is equal to 1 mole. So when you're setting up this relationship, again, it doesn't matter what the gas happens to be, but I am doing 22.4x is equal to 38.9. So I have to divide both sides by 22.4 in order to solve for x. And again, this is just so that everybody hears me and sees it done correctly. So I get around 1.74 moles for my answer here. So again, you're going to be dividing by 22.4. So I still want you to set up the proportion. I know mathematically you could see the patterns, but I want to see those proportions. So again, the last problem on this one, how many moles are in 12.5 liters of N2 gas? So try it on your own and then you're going to see the answer. So again, you're cross multiplying, you take 12.5 divided by 22.4 and you should get about 0.58. So again, always assume, it doesn't matter what the gas is. If you're finding liters or moles, always assume STP.